the tail end of going over all our transformations. And we're going to talk about every single transformation today. Now we're going to talk about whether something is congruent and what the orientation is, all with our different transformations. Now first thing y'all need to know is, what does it mean to be congruent?
Straight.
Straight?
Straight cut.
No.
That's what it sounds like.
Congruent?
Maybe it's similar.
It's same size, same shape, right?
Yes. Okay, congruent, and if you need to write this down, write it somewhere on your notes page. But to be congruent, it means it has the same size and the same shape. I'll eventually get it written up here.
Same size, same shape. Straight.
So congruent, again, is same size, same shape. Okay, that's the easy terminology to remember. Again, congruent means it is the same. It is identical. Everything about it. Okay, the side links, the angles, everything about it is the same. All right, now, the word orientation is a little bit different. Okay, the word orientation is basically the direction it's facing. Okay, the direction it's facing. Okay, it's also how the pieces of an object are arranged. Okay, make sure you're writing this down. Okay, again, somewhere on maybe at the top somewhere. So again, congruence means same size, same shape. And orientation is direction something's facing or how the pieces are arranged. So if you change how the pieces are arranged, your orientation has changed. Okay? Or and we'll talk about, the different transformations and what those look like as well. Okay? I would say orientation is a hard word to understand a little bit, but we're going to go over them with each of the different transformations. Now let's first start with this transformation. Okay? Can y'all tell me what type of transformation is this? Okay, so what is that?
Enlargement.
Okay, yes, it's an enlargement. Well, what type of transformation is that? Macy, what you got? A dilation. It's the very first one we talked about.
Multiplication.
Okay, it is a dilation. All right, you have to know what these are called. You have to know these vocabulary words. You have to know what they are called. This is a dilation, okay? And like Slayton said, this one is an enlargement. But you can also have an enlargement or a reduction. Now, this one's an enlargement, but you can also shrink something down. Now, do dilations preserve? Do y'all know what preserve means? Preserve. It means to hold. So think of, if y'all have heard of, foods that have preservatives. Do y'all know what that means? What does that mean? Do they last a long time?
Yeah.
Yes. Okay, so foods with preservatives are like, those processed foods that can sit in your pantry for, almost a year. Okay, it's because they have preservatives in it, which hold it together, keep it, so that it can last longer. All right. So does this hold or preserve congruence? Is it congruent?
No.
No. Okay, because they're not the same size. They're the same shape, which means that they are similar. These are similar figures. Now, does the figure, so going from here to here, is the figure, does it preserve orientation? Is it facing the same direction? Yes. Now let's look at the vertices. What are vertices?
Like the point.
Yeah, the point. So P, Q, and R. And then P, Q, and R prime. Okay, are those, is the orientation preserved? Are the way that they are arranged, is that still the same? Yeah. Okay, so the orientation is preserved in all matters. Okay, because we really didn't change any part of the direction. All we did was blew it up or shrunk it down. We didn't change the direction at all. Now let's talk about the algebraic representation. Okay, dilations, I heard somebody say it earlier. With the algebraic representations, what type of operation should that be? Multiplication. So remember, this is going to be multiplication. Whoops, I did not spell that. Multiplication. This should be a I. Okay. So let's actually write the algebraic representation for this example. So we know we're going to be multiplying. Now, can anybody figure out what we're going to be multiplying by? You need to look at the coordinates. Okay? Let's just look at R. Right now, R is at coordinate 1, 1. And what does R prime become?
3.
3, 3. So how do you go from 1 to 3 multiplying?
Times 3.
Times 3. So we're going to do 3 times the x value and 3 times the y value. So here's where we're really putting it all together. We're talking about how things affect the shape. And then we're also looking at the algebraic representation. Okay, so that's for dilations. Okay. Now let's look at the next one. Okay, can anybody tell me what type of transformation this is? Translation. Okay, this is a translation. And what's another word for that when you translate a shape? Slide it. Okay, again, we're sliding it. Translation is a slide. Okay, do translations preserve congruent?
Yes.
Yes, same size, same shape. Now, is the figure, is it preserved in terms of orientation?
I'm a little confused on the orientation.
Orientation's direction, the way it's facing.
Okay.
Okay? The way it's facing. So, did we change the way it's facing?
No.
No. Okay, so it does preserve, it does hold orientation. Now, what about the vertices? Did we change any order or the directions the vertices are going? No. So the orientation is preserved as well. Now, translations, what operation was that when we go to do our algebraic representation? Adding or subtracting, yes. So we're going to add or subtract. So let's look at this example here. Okay, find your original image. So I'm just going to take R, for example. And then here's R prime. So directionally, how many units did I move in order to get here? So I went 1, 2, 3, 4, 5, 6 units. Again, this is 6 units right. And then I went how many units down?
4.
1, 2, 3, 4 units down. 4 units down. Okay, so figure out what directionally, again, how you get there. Now let's write our algebraic representation. Okay, now, right, which value is right going to affect? The x or the y?
The X.
The x, because the x-axis runs left and right. So what are we going to do to the x value? If we go 6 right, plus 6. Because positive numbers are to the right. So if we go to the right, we're going to add. Now up and down is going to affect our y value. So if we go down 4, we're going to subtract 4. So there's your algebraic representation for your translations. Okay, let's look at the next one. Okay, what type of transformation is this? It's a reflection. Okay, a reflection. What's another word for a reflection?
Mirroring.
Mirror image. Yes, mirroring. It's a mirror image. Now we have reflected over the x-axis or the y-axis. The other day we also reflected over a dotted line, and then I know in math lab y'all reflected over other lines. You can reflect over really anything. Okay. Now, did these preserve congruence? Are these shapes still congruent? Yes. Same size, same shape. Now, is our figure, the orientation, is it preserved the way it's facing? No? I got some head shakes. Okay, again, think of an image. Think of when you look in a mirror. Okay, is that, I'm facing the mirror, but where is the reflection facing? It's facing me. So we're no longer facing the same way. All right, so the orientation has changed. So reflections do not preserve orientation of the shape.
But they keep the vertical.
Well, let's look at the vertices. So when you look at your vertices, let's just go clockwise. Okay, it goes A, B, C, A, B, C. Well, what are we doing over here? A, C, B, A, C, B. So we changed kind of directionally the order of our vertices. So this, the vertices are not preserved either. Okay, because they're directionally, the way that they are arranged is different. Now let's look at the algebraic representation of these. Okay, and the best way to do that, guys, is again, pick a coordinate. What coordinate do y'all want to look at? A, B, or C?
A.
Okay, let's look at A. Right now, A is at 4, 3. And A prime over here becomes -4, +3. So we only made one change. Which change did we make?
We changed
we change the x. So our algebraic representation on what we do, we did the opposite of the x value. We kept the y value the same. Okay, and that rule is a reflection over which axis? Which axis did we reflect over?
The one.
The y. Because here's our y-axis. So again, this example is a reflection over the y-axis, which the x value changed, the opposite value changed. Again, it goes back to my little watch kind of an analogy, looking in the mirror. It actually looks like it's on my right hand, so the opposite value changes. Okay, but again, on all of these algebraic representations, what have I looked at first? The coordinates. Okay, and I noticed on y'all's assignment, when was it? The 7.7 on Monday. On those multiple choice questions, a lot of y'all didn't write out coordinates. Okay, you just tried to answer and you tried to look. Okay, when you're doing the algebraic representation, you've got to write out the coordinates. And it makes it really easy to figure out the change. Okay, but you've got to write those coordinates. Now we have one more, the last one. What type of transformation is this?
Rotation.
It is a rotation. And what's another word for rotation?
Moving around.
No, because all of the other ones we've moved around.
Spin.
Spin or
Rotate.
turn. Okay, when we turn something. Okay, do rotations preserve congruence?
Yeah.
Yeah, I mean it's the same size, same shape. Now let's look at the figure, just the figure. Does it preserve orientation? Is it still facing the same way?
Yes. Wait. No.
We turn something. Is it still facing the same way?
It's not, because if you start from Z, it's in ZYX.
Okay, it's not facing the same way. Again, if I turn it, well, just notice, I mean, like anytime you turn something, it's no longer facing the same direction it was. You know, just like for me, example, I'm facing this wall. I rotate 90 degrees. I'm no longer facing that wall. Okay, so my orientation have changed. So it does not preserve orientation in terms of the shape, the figure itself. But let's look at the vertices now. Look at the way they are arranged in their order. Did that change?
Yes. Yes.
Okay, we could look, again, we could go ZYX, ZYX. Can I get ZYX going this way?
Well,
Well,
you could, but
you could.
You have to start from the right side.
Yes, and that's okay. But the way that these are technically arranged, okay, they're still can go in the same order. So the vertices, are those preserved in terms of orientation? Yes. Okay, this can be kind of tricky, okay, in terms of thinking about orientation. But the figure itself, the orientation is not preserved. Now let's look at the algebraic representation. Okay. Again, pick a coordinate. What coordinate do y'all want to look at?
Z.
Z, sure. Let's pick the original Z, which Z is at -4, +5. And after a rotation, can anybody tell me how many degrees and which direction did we rotate?
A 90.
A 90 degrees. What direction? Like clockwise or counterclockwise?
Clockwise.
Clockwise. This is a 90 degrees clockwise rotation. Okay, if we look at the new Z, the Z prime, it's now at 5, +4. So we need to figure out the algebraic representation on how we changed it. What did we do? So I like to label my x and y. Okay, how did we change our coordinates?
We went from a -4 to a positive.
Okay, yes, and we also flipped them. Okay, this is my y. I moved my y to list first. And then it was a -4, or sorry, a -4, and it became a +4, so we did opposite of the x value. Okay, so the algebraic representations, again, they're a little bit more difficult. You've got a little bit more changes happening with your rotations. But I can't stress this enough. In order to get that, you have to write out your coordinates. You've got to write your coordinates out. That way you can see the changes. If you don't, it's almost impossible to get your algebraic representations without memorizing them. Okay? All right, now what you're going to do next is I'm going to assign a quizzes, 15 questions, okay, in Google Classroom that's asking about orientation. It has just some generic transformation questions in there. So complete that, and that's all you guys got for me today. Hold on to those notes. Those notes are important. They have a lot on there.